All right, so now we want to look at a couple problems. So if we look here at problem 1, we have this sequence here where a of 1 is 1 minus a half, a of 2 is 1/2 minus 1/3, and so on. And if we're trying to look for a pattern for the a of n, so if we get that this is 1 over n minus 1 over n plus 1, you can look at the first few terms to see that this actually does work out. Now, when doing this, I like to actually simplify this a bit. So if we can combine this into one fraction, get a common denominator here, which is the n times n plus 1. So the first one is going to be n plus 1 over n times n plus 1. And the second one is just n over n times n plus 1. And so if we combine this, we get that this is actually equal to the 1 over n times n plus 1. So for part B, we want to take the limit as n goes to infinity of a of n. And so for this case, it's easier to use the simplified form, the 1 over n times n plus 1. And if we do that, we can see that this is the same thing as limit as n goes to infinity of 1 over n squared plus n, which is just equal to 0. Part C asks us to find a formula for S of n. Now to do this, it is going to be helpful to look at the first few terms of this sequence of partial sums S of n. So remember, S of 1 is just a1, and it tells us a1 is 1 minus 1/2. S of 2, remember, is defined as a1 plus a2. If we want to add these up, our a1 is 1 minus 1/2. The a2 is 1/2 minus 1/3. Now if we add these up, you can see that this 1/2 and this 1/2 actually cancel out. And so we end up with a 1 minus 1/3. For S of 3, remember, this is a1 plus a2 plus a3. Now, if we look at what these terms are, we have a1 plus a2. a3 is 1/3 minus 1/4. Now, once again, we get that this 1/2 minus 1/2 plus 1/2 cancel each other out. And then the minus 1/3 and plus 1/3 also cancel each other out. There's nothing to cancel out the 1 or the 1/4. And so we get that this is 1 minus 1/4. Likewise, we can continue this. It turns out that our S4 is going to be equal to 1 minus 1 over 5, and so on. Hopefully you can see that this pattern now is going to eventually give us S of n is going to equal to 1 over 1 minus n plus 1. So we can fill our answer into part C. We get that S of n equals 1 minus 1 over n plus 1. Now for part D, it tells us to compute the limit of partial sums. And so this ends up just being limit as n goes to infinity of 1 minus 1 over n plus 1. And so remember, this term here just goes to 0. And so we're left with that this is just going to equal 1. And so we have that this is a series here, an infinite series, where when you add up all of these infinite number of terms, they all add up to be equal to 1.